Flight Director Gene Krantz to my left. I'll turn it over to Gene at this point.
Okay, we've got, at your request this evening, Tony England over here to talk to you about how we intend to use some of the command and service module lithium hydroxide canisters. We've got Bill Peters, the Telemu, who's the man responsible for the electrical and the environmental systems, instrumentation systems of the LEM spacecraft. And Dick Thorson, who's responsible for the LEM control systems, propulsion, RCS, and certain of the guidance systems. We picked up on shift at about 74 hours and 30 minutes elapsed time. The majority of our work for the first few hours in the shift was associated with modifying the crew checklists for the dock dips burn we performed later at 79 hours and 30 minutes roughly. Now these were lists that we had developed actually for a lunar orbit insertion abort. And as such, the majority of the checklists were available in the control center for a lunar orbit insertion type contingency. And our primary problem in modifying these checklists was to make sure that we used the minimum power to accomplish the desired maneuver, as well as to make sure that we put them in proper sequence so that we didn't have any unnecessarily long power up. At around 75 hours, we got into a relatively long discussion of passive thermal control, and I'll come back to that later on. And as soon as we completed that, we went into a review of the mission rules with the flight crew. Now, we actually had a very short review when we talked to them about some of our guidance and control type rules, the rules we use for attitude and rate deviations. During the period of time we were reading them up their contingency checklist changes. Later on we came through with a relatively detailed checklist update. This took just about 45 minutes to get the checklist information up to the crew. At around 75 hours and 45 minutes we had provided the spacecraft, the state vector, and the target load for the mid-course correction maneuver we were performing. And we went through a consumable status, and I'll come back to that later again. At 76 hours and about 30 minutes, we went over the rules with the flight crew. Again, we were being very conservative on this particular burn because I think you were aware that if we did not perform the burn, we were on a free return trajectory and would splash down in the Indian Ocean at around 152 hours. So we wanted to set the limits for the crew monitoring of the burn very tight. In other words, we had to have a nominal performing descent propulsion system in order to initiate and continue the burn, and if for some reason the descent engine should start deviating in performance, we wanted to shut down the burn. Now, we were doing this primarily because we could make a small mid-course correction sometime later on in the mission and bring us back to a free return trajectory again. So we played that particular maneuver very conservatively. I believe you've probably got a transcript of the air-to-ground communications at that time, so that I don't think there's any need to go through all of the rules we read up to the crew. Now, one of the items that was of concern to us as we entered the burn was how good was the platform orientation. And we made two checks, one looking at the sun, and the other one, that's using the AOT, and the other one immediately prior to the burn, where we were looking for some kind of a bore sight to make sure we were in the right attitude for the burn. And fortunately we happened to find that the moon was on the commander's LPD. So through these two checks we felt that we had a very good platform alignment, and we had almost insignificant drift on the platform from the time that we originally oriented it just prior to the time we left the command and service module. I'll talk to you briefly. We reviewed at around 77 and a half hours. We reviewed the power down checklist, and as you're aware, much discussion ensued in getting this up to the crew later on. But our basic configuration gives us low bit rate telemetry from the spacecraft, S-band voice from the spacecraft. We've got a coolant loop up and operating. We've got suit fans on. We've got a cabin repress capability. We've maintained a RCS manual attitude control capability, and we've got the caution and warning system powered up in the spacecraft. At around 77:56, the S4B impacted. I have the precise time later on here. I'll look for it in the notes, and I believe you probably got that word. At around 78 hours and about 15 minutes, the crew started the powering up of the LEM spacecraft for the Doc Dips burn. The burn was scheduled, and I'll give you the delta V's. The burn was scheduled for 79 hours, 27 minutes, 38 seconds ground elapsed time, and the X component of the burn was 833 foot per second, and the Z component of the burn was 213 foot per second. Effective delta V was somewhere around 900 foot per second. The impact time, as we've got it from the site that was recording the transponder on the S4B, was 77 hours, 56 minutes, 40.025 seconds. We gave the crew their final target load and state vector as they came around from the backside of the moon at 78 hours and 19 minutes. And by this time, the crew was well into their activation checklist, and our electrical power main bus load was running about 40 amps. Previous to this time, we had widened the dead bands on the digital autopilot to conserve some reaction control system propellants. And at about TIG minus 1 hour, we narrowed down the dead bands and kept the communications up so we could have high bit rate telemetry throughout this entire last hour to make sure that we had a really good spacecraft for the maneuver. After, at this time, we went around the horn and made our decision on the initial LEM spacecraft power down, and we advised all the flight controllers that we would start with the power down of the LEM spacecraft at around cutoff plus about 15 minutes. We again wanted to make sure we had a good spacecraft post-burn, and we wanted to let the system stable down before we started powering down the systems on board the spacecraft. We gave them a go for the burn at 79 hours and 18 minutes, and at 79:27:40 approximately, we initiated the ullage. The burn looked very good. In fact, it was an excellent burn. Our peak current during the burn was around 50 amps, and the burn terminated roughly at 79:32. Immediately thereafter, we gave the crew their initial power down information to bring the majority of the spacecraft systems down, with the exception of the communications system and the guidance navigation system, because we had to keep that up to initiate the passive thermal control. The crew spent about 45 minutes getting into attitude for the passive thermal control, and about 30 minutes to allow the rates to damp out prior to initiating the roll rate. The tracking in the burn came in at about 81 hours and about 15 to 20 minutes. And the initial cut on the tracking said that we had had a very good burn. Preliminary indications were that we'd perform a mid-course correction 5 at around 104 hours elapsed time, and the delta V would be between 4 and 6 feet per second. It may turn out to be something less than that by the time we get more tracking in this evening. We had a long discussion on the lithium hydroxide canisters, and I believe Tony can fill you in on whatever questions you may have there. We got into the attitude for PTC at about 81 hours, We gave the crew a total briefing on the consumables, and I'll summarize the consumables as they stood at around 81 hours, 24 minutes elapsed time. The electrical system, we had 1,498 amp hours. This means that we must maintain an average load in the spacecraft of less than 24.5 amps. At the present time, we expected to be able to power down to around 14 amps main bus current. We're running somewhere around, I guess, 13. Is that right, Bill? It's running 12 to 13 amps right now, so looks like we'll start making some money in electrical power system throughout the night and throughout the next day. From a standpoint of water, we got 215 pounds usable. Some broken communications. It has not happened yet. It seems we've got a good stable PTC. But if the communication should become broken, we may be able to communicate to them only 50 to 75% of the time. So we gave the crew gross procedures they could use for selecting the antennas for us to allow us to communicate with them much more of the time. And that was about it. We got off shift at around 82 hours and about 30 minutes.
Okay, why don't we open it for questions now? Please hold your hand and wait for the mic. This gentleman over here.
Mr. Krantz, can you tell us two things? There was a report of what may be some new venting. Can you tell us about that? And can you tell us what sort of physical discomfort the crew is in at the moment?
From a standpoint of new venting, we had not been aware of any venting during our shift. As you're aware, we had some problems in establishing our passive thermal control, although we finally established it. It looks good, and we thought the problems, in as much as we were using very low thrust pulses on the RCS system, may have come from the sublimator in the LEM spacecraft. So that is the only knowledge I had now. There may have happened something in a subsequent shift. When did that occur?
Just about the time you were changing, I think. There was this report that they had seen some new gas, and they were asking them from here whether it was residual from the original thing or whether it was new, whether they thought it was new.
About the majority of the pre-burn type procedures and post-burn type procedures, and I believe Jim Lovell's the
because he's
man that seems to be somewhat behind.
Now.
We're trying to work up some kind of a crew rest cycle right now to give them all an adequate amount of rest between now and the possible mid-course correction at 104 hours.
Art Snyder.
A couple of questions. How much better off are you on consumables tonight than you thought you might be last night? And secondly, what does a flight plan call for the next 24 hours?
I'll answer your last question first. The flight plan for the next 24 hours is basically going to be passive thermal control, minimum activity, and we're going to stay powered down as long as we possibly can. Let's see, what was the other question you had? I'm sorry.
I was wondering about the consumables and how much better off you are than you thought you'd be tonight.
I think that, at least from my standpoint, I feel we're much better off than we were last night. I thought we'd have to maintain our bus levels at about 14 amps throughout the rest of the mission, but it looks like we have a bit more flexibility, and I think tomorrow we'll have a much better hack on this, because I think the key consumable now at the present time seems to be water. So once we get a hack as to how much water we're going to use in a fully powered down state, then I think we'll be able to give you a good answer. But from my standpoint, it looks a lot better now than it did last night. Although, again, last night we had the capability of coming back. We just got a better margin to work with, more flexibility now.
Carl Abraham.
Could we have a rather detailed explanation of the tests that were run in the simulations with the lithium hydroxide canisters, and a description of how this hose is being attached or will be attached to a canister, and particularly what hose that is? Where does it come from and what's going through it?
That, and he brought you over one of
our
the canisters.
This is our mailbox. As you know, we use the lithium hydroxide to scrub CO2 out of the spacecraft atmosphere. Okay, I'll talk more directly into it. We have a limited amount of lithium hydroxide in the LEM, and it would relieve a lot of the pressure on the environmental control system if we could use some of the canisters, lithium hydroxide canisters from the command module. So actually Jim Corielli over in Crew Support Division, who designed this thing, and it does an excellent job. What we do is we use the suit loop in the LEM, and this is the scavenging hose, the exhaust hose, if you will, from the suit. And we just put the lithium hydroxide canister on the end of it, and it's not so easy to fasten on there. We've used a data card out of the flight plan to make a structure so that the plastic cover here won't collapse on the end of the hose. The canister itself is coated with Teflon, and none of our flight tape would stick to it, so he designed sort of a grid system that goes around it that allows us to fasten things to it. And we've had one of these running for about 3 hours over in the 11-foot chamber in Crew Systems, and all indications are that it's doing the job. I understand that we have about 16 cartridges in the command module, and each one will have a lifetime of about 12 hours. And we'll be running 2 at a time, one on each of the suit loops in the LEM.
I have a number of questions about the test and also about one condition in the spacecraft. Are we correct in assuming that they're still running at 5.5 psi in the spacecraft now? And what was the pressure and the absolute pressure and the partial pressure of carbon dioxide at which you ran the canister tests?
The canister test isn't complete yet, and the last I saw it was just building up. I'm not sure. I think it was 20 millimeters of water pressure that we were going to build up to in the test, and we're not going to allow it to get above 15 in the spacecraft. The test isn't complete yet. It takes several hours.
The other question was, is the cabin atmosphere in the spacecraft now at 5.5?
Yes, I believe that's right.
Bill?
It's closer to
4.7.
Sorry.
4.7, 4.8.
Dr. Kim?
What is the humidity situation and how do you control the humidity?
The LEM has some water separators in the suit loop in the lunar module, and they are working, and they're separating the water and controlling the humidity properly right now. There's no problem with humidity.
Mark Bloom?
Gene, you've always been recognized as the LEM expert. How would you classify the LEM as a spacecraft that can get these men back to Earth? Would you say it's in good shape, and how is your confidence factor compared to, say, last night at this time?
It's interesting, Bill. I forget when we got started. I think back in Apollo 9 we first started looking at the use of the LEM as more or less a lifeboat. And fortunately, although the exact procedures do not tailor the exact case we've got, we had looked at the utilization of the LEM for an awfully long time, so we knew what the limitations were. We developed workaround procedures wherever it was possible. I think the LEM spacecraft's in excellent shape, and I think it's fully capable of getting the crew back. I think, as we have found before, every time we've put the LEM spacecraft to a test, it's always done much more than it was guaranteed to do, and I think this is a good case in point.
What was your confidence factor anywhere near this high last night about this time?
Yeah, it was, let me put it this way. Last night I felt we were going to have a much trickier management problem in our hands. It is not the easiest right now, but I thought that the overall management of all of the energy, the water, all the consumables in the spacecraft were going to be quite difficult. And I think one of the things that was very pleasing to me this morning, or when I got on shift at around 12 o'clock, I guess it was that we were still running at relatively high power levels, but our consumables rates had steadied down to slightly less than what we had anticipated, and we were also happy that we were pretty well off in the RCS system. So from that standpoint, I think we have a tricky management problem coming back, but I feel that we've got a good handle on the situation and know how to manage it.
Jack Jones.
You described the crew as reasonably uncomfortable. What's the discomfort besides maybe the tension? Is there some physical?
No, I'd say that the primary discomfort would be from trying to rig up some adequate sleeping capabilities in the LEM spacecraft. I have not had the opportunity, maybe Tony can answer a question on that. I really haven't looked into that in detail because our primary job has been managing the systems and getting ready for this burn. But I believe it would be primarily in getting those guys into a point where they can sleep comfortably in there while somebody's moving around using the communications and making periodic checks in the spacecraft systems.
Well, you don't.
That's right, they could very possibly be. I guess I ought to correct myself.
If they're testing this canister setup, how are they handling this in the spacecraft at this time?
Well, it's not necessary to put this in the circuit until sometime tomorrow. We're going on the secondary canister in the LEM any time now. The CO2 level is getting up near 15. And we'll have, I believe it's 8 hours. Is that right on the secondary?
Yeah, we've got 3 additional
Comes when crew members awaken in the morning, if I remember right from the flight plan. That's right in the front of your flight plan. I didn't have any crew status reports in my shift, and the doctor did not indicate that they had any problems. So that was basically the status we had when we left.
Paul Racer.
Gene and perhaps Dr. England, I'm sure y'all have gained a picture of possibly of what life is like up there. And I'd kind of like for you to share it with us. Are they, there's some confusion about where the astronauts are spending most of their time. Are they all huddled in the LEM? What are they wearing? Are they having to dodge some foods because the salt content would make them crave water? This sort of thing. Any observations like that would be useful.
Well, they seem to be spending one fellow in the command module all the time, 2 in the LEM. The guy in the command module should be sleeping, but these fellows are pretty diligent, and I'm beginning to sense that they're taking a lot of pictures of the moon and the Earth, and they're even doing some studies on some of the particles that are flying off the service module back there. I don't know whether that answers all of your question. I wouldn't describe them as all huddling down in the LEM. They're pretty busy. Yeah.
Paul Racer.
Are they dodging certain foods because this would make them crave water, for instance?
I don't know. I haven't heard anything like that.
Jim.
What garments are they in? Do you know? Are they constant wearers?
Well, they'll be in the constant wear garment with their coverall.
Jim Maloney.
2 unrelated things. One, is there any way for the medics to know what their condition is? That is, if any of them at any time in the biomed harnesses? And the second thing is, has anyone come up with a way of finding out what the cause of this explosion or accident is?
To answer your first question, yes. We're looking at biomed data tonight on, I'm really not sure. I think it's Fred Hayes. And what we're interested in there is to just monitor his condition as a function of, I'd say, a backup measurement of any possible CO2 buildup in the spacecraft. Now, we don't expect that, but we are monitoring it. The problem we've got there is that since we are operating in a low bit rate mode with the spacecraft on the Omnis, we do lose some signal margin there. And if this turns out to be a problem later on in the evening, we'll probably switch off the biomed instrumentation, because what it amounts to, it wipes out the rest of our other instrumentation at the power levels we're at. from a standpoint of what's being done to try and determine the cause of the explosion or whatever the problem was that happened in the service module equipment bay in the area of the cryo tanks and the fuel cells. I really don't know, Jim. It's pretty much tough staying on top of our job without worrying about what happened many hours ago. Now, we are looking pretty deeply into the entire status of the command and service module, and we're trying to come up with, tomorrow, for instance, we expect to read up to the crew more or less a standard configuration we want them to go to for all of the switches, circuit breakers, and everything in the command and service module. We're looking for to see if we can make a test to verify whether the main B bus has any problems associated with it. And then tomorrow afternoon, we're spending a large amount of time looking at such things as reentry checklists, and particularly from a standpoint of establishing a timeline for separation from the service module and subsequently separation from the LEM spacecraft prior to coming into our entry interface time. So the primary work we've got going in the command and service module is to make sure we got a good one and do whatever troubleshooting we feel may be necessary, and then to really shake down those procedures.
This gentleman here.
Can you explain this collecting of water they're doing in the plastic bags, where they're getting it or what they're going to do with it?
Yeah, I believe that's, they're collecting the water for their drinking and food purposes from the service module potable tank, and they're just using their normal procedures. Remember, they used to have this technique they use for separation of the H2 that may be in the tanks from the water. So it's just normal water collection procedures in the service module, or in the command module.
Okay, let's take Carl Abraham and then two more questions. We're going to have to break it and let these gentlemen get some sleep.
We were told before the burn that two people would be in the LEM and one would be in the command module. And later on I got a part of a quote which seems to indicate that maybe that wasn't the case. This quote was, "He's the only CMP that's ever witnessed a dips burn sitting on the SN engine can," which would lead one to believe that all three of them were in the LEM at the time of the burn.
Yeah, this is a interesting item. Yeah, all three crew members were in the LEM at the time of the burn, and we had computed our dips gimbal trim position for the man in the command and service module spacecraft, which caused a center of gravity movement that caused the engine gimbals to compensate for the fact he was in there. So we saw that excursion, and then once we found out that, yeah, we had a CMP in the LEM spacecraft, we knew why the excursion.
Okay, let's take Art Schneider. Oh, yeah, followed up with one, Carl.
Would you care to speculate why all three of them got together in the LEM at that time?
I think the third man wanted to see what was going on.
Art Schneider and then John Harris, and we'll close it.
In the discussion of food about mealtime, was there some fear of contamination of some of the food in the command module?
Not to my knowledge. I didn't hear any. Tony, did you? Or Bill or Dick?
They were trying to find something that would use less water.
Is that right?
That's all.
Now, at the time they were going into mealtime, we, as you were aware, were having some problems in establishing our passive thermal control, and that became an end in itself for about a half-hour period there. And generally during that periods of time, we hand over either to the assistant, generally to the assistant flight director, to be following the normal course of the mission.
Okay, let's close it with John Harris.
What single factor, if any, is giving you the most concern at this time?
Gee, it's probably one that I'd say the one thing, if anything, is bothering me is a large amount of checklist changes we're making. That's why we're always trying to stay several days ahead of them and verify them in the simulators, because once you've got tried and true procedures, you like to stay with them. And I think we've gone through the major portion of the checklist changes now, so I think we're pretty much over the hump from that standpoint. It's always nice to be operating in a mode where where you're actually using procedures you've used before, and that's a good way to be.
Checklist. By checklist, you mean re-entry checklist? Does that mean the re-entry is giving you concern?
No. I'm saying all the checklist changes we had made up to date. From a standpoint of discomfort, that was about the major item, because I think we felt we had a good handle on how to manage the systems now and how to go about making this burn. We had made long dock dips burns, for instance, back in the Apollo 9 mission. So we were pretty confident of those procedures.
Thank you very much, gentlemen.
Just to explain to everybody what I think this is about, so some of you can go start drinking coffee again. I had about 20 requests for interviews today, and obviously I couldn't handle that many. So I decided everybody that was interested in interviewing me would try to get them all together at once, and I try to talk to them, and that's all this is all about. I have absolutely no briefing as such to make and no statements to make. I'm just available for questions. So if anybody didn't understand it that way, why, I apologize, and you're free to do anything, obviously. Roy?
Yeah, Dick, at this stage of the game, we always start thinking about post-recovery plans. And I wonder if you could give us any kind of a fix on, assuming everything goes well, you have a recovery tomorrow, what are the plans for the crew?
Yeah, I just happen to have a draft here in my vest pocket, which we haven't printed yet, but the last thing I got from the recovery guys would be arrival at Ellington at 8 o'clock Sunday morning. Now, the times before that, Roy, I'm not too clear on, but in rough numbers, we'll keep them on the carrier overnight. Tomorrow night, go on into Samoa, pick up a C-140 from there, and then non-stop into Ellington. And those exact times I don't have. But they end up at Ellington at about 8 o'clock on Sunday. We would then start debriefing Sunday afternoon, technical debrief, and all day Monday. Have a program project debrief on Tuesday, follow-on crew debrief Wednesday, and on down the line. I can give you all that detail if you wanted, or just a little.
We would be interested in it, and of course, too, most of the news people in this room would be interested in when would we, do you think, get a chance to talk to them?
Okay, well, let me follow on through then with the rest of this since we're on the subject. Thursday the 23rd, then we would program a photo debrief, whatever science we got, which obviously isn't much in this case, that morning, medical debrief in the afternoon, and then finish the day with working on a pilot report. The same on Friday and Saturday, give them Sunday off. Monday and Tuesday we'd program systems debriefing, detailed systems debrief with the experts. In this case, of course, we anticipate that this is going to be a fairly lengthy process, considering our problems, whereas on the last missions where things have gone clean, about one day has been enough of that. So, as a preliminary, that looks to me like we come out with a press conference on about the 29th, Wednesday the 29th.
Would you think in terms of an earlier news conference than that, just perhaps a short one?
There has been some discussion of that, but I think that, again, is a decision to be made by Dr. Payne and Bob Gilruth, and if somebody decides that it's desirable to fit one in there someplace before that, I'm sure it'll happen, but this is the only plan that I can draw up at this time.
Okay, thank you.
All right.
Yeah, Deke, can you give us a fairly thorough rundown of Tuesday night, Monday night in the simulator? Gene Cernan and Joe Engel spent the night. What did they do? What kind of problems were they looking at? How long were they in there? That sort of thing.
We've had people in the simulator all night and all day every night and trying to figure out exactly what happened Monday night. At this point, it's got it difficult for me to backtrack. We're in the running right now and have been part of the night on the reentry part of the stuff. Essentially what we've been doing in the simulators is looking at what our next milestone is, the things we don't have a good detailed checklist on, and trying to work out the details in the simulator and feed it on up to the crew. I think the things we were working on Monday night, we were concerned about PTC using the LEM instead of the command module, which we hadn't done before, and worked that out in the simulator. Of course, we worked out the AGS PTC thing that we've been doing here the last day on the simulator. We worked out the AGS dips dock burn on the simulator, the one that we made last night. There again, we have contingency procedures for dock dips burns, but we assume you do those with the pings nominally instead of the AGS. So it's these kinds of things that we've had to vary due to the particular situation that we're in, that we've tried to work the details out on the simulator first.
Dick, two questions. First of all, from what you know of the conditions, can you give us some idea of what it's like up there for the men? And secondly, is there anything in particular that's impressed you? They've obviously all done magnificently, but anything in particular that's impressed you about their handling of this emergency?
Well, as far as the conditions, nothing unusual about them. They're a little colder than normal up there, of course. The command module was running about 52 degrees the last count I had. The LEM was reasonably warm. So it's colder than we're used to, and of course with the command module powered down, it's darker than you're used to, but that's no big problem. I think in terms of crew comfort, we don't have any problems. We're in good shape. We've got enough food and water and so forth, and I guess if you want my opinion of how they handled the situation when it happened, they handled it exactly like we'd expect them to. They were about as well on top of it as anybody could be. We knew on what we knew, which isn't very much, I'll have to admit. But I think they did everything right within the knowledge that was available to us in a timely fashion, which is what all we expect of them. I think they did a beautiful job of it.
Deke, how is Ken Mattingly's health now? Any signs of rubella?
Well, just talking to him before I walked over here, I still don't see any spots on him. He seems to be feeling reasonably well. Yes, sir.
Slayton, we've had reports of haggard astronauts spinning wildly off course. How haggard are they, and how wildly were they off course?
That doesn't mean a thing to me. I don't even know what you're talking about. I don't mean to be smart. I really don't know.
Are they haggard?
Are they haggard?
Yeah.
I don't think so. They haven't had as much sleep as we'd like to have them have, but nobody else has either. And I think if you can get 4 hours here and there, well, you're in pretty good shape. I think they're rested enough to do a reasonably good job. The spinning off course thing, I frankly don't understand that. I don't know what that means.
Are they more off course than is normal for a ship returning from the moon?
Off course?
Yes. In other words, they needed a course correction to get back on the corridor.
No, we made a mid-course last night, which is normal. We haven't...
Normal? Was it an abnormal correction?
No, totally not. I guess that's what's confusing me here. There's been nothing abnormal about the trajectory at any time. We were on a hybrid trajectory at the time the incident happened. We burned back onto a free return, and then we made the burn on the loop around PC plus 2 to get us on a faster return. We expected that we'd have to make a mid-course on that burn, which is the one we made last night. And you're a little bit out of the quarter until you make that burn, but that burn is insensitive as hell. You can make it about any time and in almost any direction, as long as you're pointing approximately. So as far as trajectory, we haven't been concerned about that at all at any time and still aren't. We may make another mid-course somewhere around 5 hours, someplace in there. It could come out a couple feet per second. Whether we make it or not doesn't make a bit of difference. It just tunes things up a little bit.
How would you evaluate the value of Jim Lovell's previous experience in space and coping with the emergency, and does it raise any thoughts in your mind about the advisability of having an experienced man in the crew in future flights?
Well, that's a tough thing to put a handle on. I guess you aren't experienced in anything until it happens to you. This particular thing hadn't happened to any of us, so he wasn't any more experienced in this particular thing than anybody else. On the other hand, I'm sure the fact that he's been there before is bound to have some benefit. Try to put a number on it, frankly, I can't. But I think we've always felt that we can start in with anybody and train them up to the condition where they can fly a very good mission, and the experience factor isn't all that great. Because if we really didn't have that capability, we wouldn't have flown to begin with anyway. You just have to assume that you can train people to do anything that's required of them on the ground when you're in the space business.
Say you're not concerned about the trajectory. What is your chief concern now in the next 24 hours?
What is the what?
What is your chief concern in the next 24 hours? You say you're not concerned about the trajectory. This is going well. What are the chief concerns in the next 24 hours?
The main concerns?
Yeah, what is your chief concern, yes, in the next 24 hours?
Oh, I think I don't have any great concern. We've got some work to do, lots of it, and it's primarily concerned with the entry. We've got an unusual combination of things here. Number one, we have nothing in the service module, which we normally have, to provide sustenance to the command module. Normally you keep the service module on, which provides you power and oxygen up until somewhere around 30 to 40 minutes ahead of the entry. We haven't got that. So, and we do have the service module on, and it's given us some thermal protection. So we're caught here in one situation of wanting to get rid of the service module reasonably early. On the other hand, we've got to make sure we don't get rid of it too early and give us some thermal problems. Secondly, we want to keep the LEM as long as possible, because this is where we are getting the things we normally get from the service module, at least to a limited extent. So trying to work out this timeline from both ends gets to be a little bit sticky, and we've got a preliminary one that's been worked out yesterday through the night last night. We're simulating it this morning. We hope to have it in pretty good shape by noon today. We may have to do a little more work this afternoon.
Do you expect any problems, in fact, in the jettisoning of either the LM or the service module?
No. Right.
Questions. Presumably, with your...
Prepare for entry.
Our preliminary plan right now is to dump the service module around 4.5 hours, and to dump the LEM at about 1 hour. I'd make it clear these are preliminary at this point because we've got a lot of work to do yet. We would like to back the service module jet out farther if we can reasonably, and we'd like to hang on to the LEM as long as possible. And so what these times turn out to be is going to be a function of how well our timeline integrates.
How will you achieve separation in this case from the service module and from the LEM?
I'm sorry. Well, with the LEM attached in the service module, we can just put a little delta V in with the LEM and separate from the service module. That's no problem there. And of course, separating the LEM, we got this pop gun effect. We have a delta P in the tunnel, and as soon as you pop the ring, why, you're going to get a separation of something like 2.5 to 3 feet.
And finally, have you figured out yet what you think happened down there in the service module?
No, I sure don't have any wisdom on that subject at all. There's all kinds of speculation, but I don't think anybody knows the facts, and we probably aren't going to for a while. We hope to get some pictures that might help give a little enlightenment to the subject, but there again, we can't plan too heavily on that either. We'll do the best we can with it.
That knowledge would affect your planning for future missions, wouldn't it?
Oh, it definitely.
You'll have to do systems analysis, pin it down.
No, I don't think there's any question. We have to understand this before we can probably commit too much farther. It's a kind of a failure that can give you a pretty bad day if you don't have the LEM around.
Has there been, or is there likely to be any more discussion about the members of the astronauts' families possibly talking with the astronauts before reentry?
I don't see any particular reason for them to do that. I doubt if we're frankly going to have time, and I'm not sure they even want to. But if they've expressed an interest in doing this...
You said
pardon?
You're not sure they want to?
I don't think it's even been discussed with them. At least I haven't discussed it with them.
Dr. Payne has, hasn't he?
Pardon?
Dr. Payne has he not?
I don't know.
Number on this, but do you have any idea how many people in and out of NASA, that would be NASA and industry personnel, worked out the solutions to the problems that Apollo 13 encountered in flight? And also, casting back over all that's happened since Monday, if you had 3 decisions to pick out that you think were the key ones, what would they be?
Well, to answer the first question, you're right. There's an awful lot of people who have been working the problem. We've had here, and of course, the whole contractor support base, Grumman, North American, MIT, Ham Standard, everybody that's had a piece of this thing have had their people working the problem. So I'd expect, in terms of the numbers, you could say it's about the whole government industry team that's been working Apollo as a steady-state process. I don't know what that number is.
Hundreds or thousands, do you think?
Oh, it's thousands. If you want me to pick one, I guess it's somewhere between 50 and 100,000, I suppose. It's awful hard to put a handle on that. You've got to go way down through the primes alone. I'd guess come out somewhere in that
What was that number?
I'm making a wild guess here. If you want a number, I think we ought to have our PAO people. Howard Gibbons can probably get you a number. I'm not a statistician when it comes to those things. Let's see, your second question was, what was the most critical decision point? Oh, that's a tough one to answer. It's kind of like we say when we talk about a mission, from takeoff to landing. And in this case, it's kind of been about that. Well, I don't think any decision was really very tough because we didn't have a whole lot of alternatives. Probably the one you'd prefer not to have to make was to essentially crank up the LEM and use that as your prime mode of operation. But that wasn't a very tough decision because we didn't have any choice. So that's kind of been the way, you've got a certain number of options, but not too many, and none of them turn out to be too tough a decision. It's a process of technically figuring out the best way to do something you have to do anyhow. And I don't know if I answered your question or not.
Deke, are there reasons other than thermal protection that you have kept the service module for this long? And could you go into what kind of thermal protection it gives, how this works?
Well, the heat shield on the command module, for example, the main heat shield, of course, was not designed to operate in free space for extended periods of time. It's designed for re-entering the Earth. And there was some concern if you jettison the service module real early that you'd cold soak that heat shield and possibly get debonding or some other problems. It's just an area that hadn't been looked at in great detail. We understand how it works with the service module on, so for that reason they preferred to keep it. Of course, the other thing you've got is we've still got the RCS quads on the service module, which are usable if for some reason you had to use them. You can take in a real extreme case. I gather there's been some hand-wringing about that mid-course last night. Well, man, we could start in, we had the dips. Okay, that didn't work. We got the apps. If that doesn't work, we got RCS on the LEM. If that doesn't work, we still had the quads on the service module. And if that didn't work, we'd have probably gone to the big engine, you know, whether we thought it was going to work or not, if we thought it was important. But before we got to that point, I suspect we'd have taken what we had and come in and entered. It wasn't that big a deal. So that's kind of the factors that entered into it.
Has any decision been made about a second burn? And if that doesn't take place, what difference in terms of distance would it make to the splashdown point?
If we do not make another correction?
Yeah.
I don't think we know that yet. We still got to do some more tracking.
Would it just be a marginal distance, or would it be considerable?
No, I don't think there's any question. We're in a return trajectory right now that's going to be an entirely safe and nice clean, and we'll probably land as close as we're going to land anyway. But probably want to tweak it up. And I don't think we're just going to know that until we spend a lot more time tracking. But it'll be a very small correction if it's any.
Deke, how much concern, if any, do you have for those chunks of debris, things like a 4-inch piece of metal that floated by the window, as it pertains to entry?
I don't think that kind of stuff's going to bother us much, because that's all going to be behind us when we get... In fact, the things like that should have disappeared behind us when we made that burn last night. That would have given us enough delta V to separate from whatever might have been floating around up to that point. Now, if you assume that some other things are going to bust loose someplace in the interim, I think we're not really very concerned about that.
Could you give us an idea of the temperatures inside the command module and the LEM? We've gotten some reports that the astronauts had experienced some very cold temperatures. And could you give us a range of the temperatures inside these modules, and perhaps of the latest reading?
I didn't come over here with all the numbers on the latest status of the spacecraft. Glenn Lunny and Milt Windler have those. I'll give you my best guess on what I remember on it, and I think the command module was 52, the last data point I had. The exact LEM temperature I don't have a number on, but it's comfortable.
Deke, from LEM separation on down to interface, do you expect this reentry will be quite nominal all the way?
Yes.
There are no special plans being made for that particular area of the flight then?
No, we intend to bring up the pings in the platform and make a normal reentry.
Thank you.
Now, if we, for some reason or another, don't get a good alignment or something, we can always come in on EMS anyway. We think we've got about a 25-mile capability just on EMS alone, so we're really not too concerned about it. But we'd like to have everything going for us we can, obviously, and try to make a good normal entry.
The unrelated point there, when you have the pop gun effect to separate the LEM from the command module, and you say the separation is just a matter of feet, how do you keep that tail of the kite from crashing into your command module on the way down? Is there anything that you've worked out on that, or is that not a concern?
By feet, I was talking feet per second. So if you've got for example, a 2 foot per second separation, you're separating 120 feet every minute.
So you don't see any hazard from this thing being that close?
No.
You just mentioned that when the DPS wouldn't have worked, you would have tried the APS, and if that wouldn't have worked, you have to try the reaction control system of this service module. Wouldn't you turn that around and first try the reaction control system before using the APS, because you would have to lose the descent stage then of the LM?
Oh, that's all speculation. The only reason I went through that sequence is to explain to you that this is an ace in the hole way down the stack if you had to use it, which is very, very improbable. If you got to the point where you had, then we'd have got around to worrying about how you were going to do it, and you had all kinds of time to worry about that. So I don't want to mislead you on that subject.
No, I understand that, but it's just that I thought because the decent stage contains all the consumables and so for the hours needed until splashdown, so
Yep.
you would rather use reaction control system first before...
Probably, yeah.
Thank you.
I didn't mean to outline a program plan here for that operation. I was just trying to make a point here in terms of...
Is there any concern that the heat shield might have been damaged by whatever happened in the service module?
No, don't think so. I haven't had any concern. Talking about a radial separation, the exact attitude, we haven't really got that in our plan yet. But
how do you see the water situation?
I think we're fat. We got 162 hours, the last count I had, and that doesn't count our 20-pound contingency, so I don't think we have any concern at all about water at this point.
Has a decision been made about wearing the spacesuits during re-entry period?
No, it hasn't. We're still vacillating around on that one. There's some advantages to it. There's a lot of disadvantages. We've got to do some more stirring around on that subject.
Mattingly wasn't seen around the control room last night during the burn. Does that have any significance?
You say he was or wasn't?
He was not seen.
Oh, he was not seen. Okay.
Yeah.
He's probably overworking on these procedures that we're simulating this morning.
What do you see as the most difficult steps on the separations preceding reentry?
There's nothing really very difficult about any one of the procedures by themselves. They're all straightforward, and we know how to... I'm sorry, I'm not hearing you.
They're not difficult, but relatively difficult.
Well, no, I think the point I was making, maybe I didn't make it very well, is that the problem is one of integrating all of these procedures into a reasonable timeline where everything fits, gives the crew adequate time to do everything we have to do. It's not any one procedure by itself that is all that difficult. They're all fairly simple and straightforward, and we know how to do them. It's just the problem of trying to keep the LEM as long as possible. If we have to make a mid-course correction, of course, that, again, adds a little more into the timeline. The fact that we've got to be playing games with the power between the LEM and the CSM. These are the kinds of things that, it's not the procedures, it's the time it takes to do them and trying to fit them into a limited time span here.
An S4B tracking picture taken Monday night showed what appeared like an explosion in the vicinity of the Apollo. Does it have any bearing of your study of what happened?
I'm sorry, would you repeat that? Either my ears are bad or that mic is, I'm sure not getting these questions or everything.
S4B tracking people have taken a picture which showed what appeared to be a bright and increasing spot in the vicinity where the CSM was supposed to be at the time, and there was some speculation that it might have indicated an explosion on the SM.
On the S4B?
They were tracking the S4B, and suddenly in the same vicinity there appeared this bright spot.
I see. I hadn't heard about that. I frankly don't know anything about that.
Dick, I think that he's referring here to a photograph that was made here which shows a cloud around what our people think was the spacecraft in S4B that they speculate it might have been the venting of, at the time the accident occurred, of the oxygen. That's what he's referring to.
Okay, I'm sorry. I'm not familiar with that.
We have information on that over at the News Center if you come over after this is over with.
Slayton, nothing seems to be difficult, nothing seems to be of concern. Do you feel the situation has been over-dramatized from the moment of this fuel cells going offline?
I guess I haven't been paying much attention to people's interpretation of what's happening, so I can't answer that question. I would not underestimate our concern. We were damn concerned. Monday night, no question about it. But we've got things well under control. I have had now since the middle of the morning on Tuesday when things stabilized, and I don't think, sure, we'd like to get that thing back, because if things keep going the way they are, we're in beautiful shape and have been. But you can't discount the fact that something else might crap out on you before you get home, you know. So, no, I wouldn't want to minimize the fact that we were concerned. On the other hand, I'd also like to make it clear that as long as things kept going the way they were, once we got a handle on the incident, we weren't concerned about getting the crew home safely.
Is there any discussion about whether the command module hatch will fit okay into the tunnel, having been open this long and so forth? Is this part of the reentry thoughts and so forth?
We may make a fit check on the thing if we have time, but we're not really very concerned about that, Art. That hatch has been very reliable. It's simple to install, and we think it's a very low probability that that thing won't work as designed.
Dick, again, you may have gone into this before I got here, but what is your latest report on the weather? And is there any possibility that the craft may be enough off course to hit this tropical storm that's running around out there?
The last report I had on the weather was no sweat. It's better than it's been, and it wasn't ever very bad. They've had airplanes flying through the area and haven't been able to find the so-called storm. And right now, it's apparently clear down there.
Duke, do you plan to transmit a new checklist once you do work out these rather complicated procedures?
Yes.
And this will be kind of the first time that they've had such a checklist, and everybody will be kind of, except for the Sims, will be doing it for the first time. And do you have any estimate of when the first of these procedures would start in Central Standard Time, or whatever time you want to name, and when they would end?
No, we're running. We want to run those things end to end on the simulator. We started that first thing this morning, and we're running right now. And we want to go through that full thing from one end to the other. I'm sure we'll run into some things that we don't like, and we'll want to change them and rerun those. So I cannot extrapolate an exact time when we would be able to read those up. But obviously, the sooner the better, within reason. If we can get them up to them this evening, why, we're in good shape. And I'm sure the crew's up there stirring around on their own, looking at a few things too.
That about it?
Any other questions?
I think that's about it.
Okay, thank you.